In understanding how the atmosphere works, we have developed ideas and theories that help us explain what we see. Two of these are air masses and fronts, and it is vital to know about these when trying to study the weather. Let's look at air masses first. An air mass is a large body of air in which horizontal profiles of both temperature and humidity are more or less constant. Air masses come from what we call source regions. This is where they originally developed their characteristics. Given time, air will pick up the qualities of the surface that underlies it. For example, if the surface of the Earth is cold and wet, then the overlying air will eventually, given enough time, also become cold and wet. Likewise, if the ground is warm and dry, and the air overlying it remains there for long enough, it too will become warm and dry. Where we see this phenomena happening is in areas of high pressure or anticyclones. The winds are usually calm, and the air can remain long enough in an area to take on the nature of the underlying surface. Air masses are stable at their source. The source regions for air masses are principally these. It is only when the air within a distinct air mass moves away from its source that we get complications. If the air moves to a warmer zone, it will be warmed from beneath, increasing the lapse rate, and will therefore become more unstable. As a result of the warming, the relative humidity will also decrease. Conversely, if air moves from its source region to a colder part of the globe, it will be cooled from below, decreasing the lapse rate, and hence become more stable. As a result of the cooling, the relative humidity will tend to increase. Air masses are defined by their source region. When considering temperature, we have three classifications: Arctic, polar, and tropical. Although note that Arctic is really a more extreme example of polar. For humidity, we have two categories: maritime and continental. Combining these, we get a full list of air mass names: polar maritime, polar continental, tropical maritime, tropical continental, and also Arctic air. These have abbreviations of PM, PC, TM, TC, and A. There is also a hybrid one called Returning Polar Maritime, RPM. Looking across the world, we can state where these air masses will form. This is what the distribution looks like in January and in July. These air masses have distinctive influences on the weather for certain locations. We are going to consider Europe and look at how all of these air masses affect that region. Choose an air mass. Polar maritime. Polar maritime air approaches the British Isles from the northwest. Its source region is the North Atlantic, where it is stable initially, but when moving south, it will pass over warmer surfaces, and as a result, be warmed from beneath. This will cause it to become increasingly unstable as it approaches Europe. Its relative humidity is quite high, but it has good visibility associated with it. As a result of the instability and a relatively moist airflow, we tend to get cumulus and occasionally cumulonimbus development, so showers can be expected, perhaps even with hail and thunder in certain circumstances. These showers usually die out inland overnight, although persisting on windward coasts, and as a temperature inversion develops at night, the wind becomes light, sometimes allowing radiation fog to form in low-lying areas. Daytime flying conditions are quite bumpy, caused by the instability and the overturning of the atmosphere. Polar continental. The polar continental air mass is stable, very dry and cold, and emanates from Siberia or northern Russia. It mainly affects Europe in winter, spring and late autumn. It has little moisture since its origin is continental, therefore bringing cloudless but bitterly cold conditions to much of the country. If there is sufficient track across a sea like the North Sea, there will be enough warming from beneath and picking up of moisture that convection can take place. On occasions, this convection can be extremely vigorous, with snow showers resulting on eastern coastal areas. Visibility is usually excellent, but will fall in any showers. Arctic air mass. Arctic air comes down across the British Isles in strong northerly airflows. The air quickly becomes extremely unstable as it moves south across the relatively warm ocean, bringing snow showers to many windward-facing coasts. Polar lows can form in this air mass. Tropical maritime. The tropical maritime air mass is the most common to affect Europe. The source region is the mid-Atlantic around the Azores, and so it approaches from the southwest, cooling from below on its northward track, increasing its stability. Since only the lower layers cool, only low cloud is produced with poor visibility and advection fog, especially on windward coastlines. Inland conditions are often slightly better, but still relatively poor, with extensive low cloud. Inland in summer, however, there is usually enough insulation from the sun to lift and occasionally break the cloud into shallow cumulus cloud. In fact, on occasions, vigorous convection can be triggered inland, with cumulonimbus, heavy showers and thunderstorms set off. Visibility is quite variable, being very poor on windward-facing coasts, with extensive hill fog, but inland is often fairly good, especially to the lee of high ground. Tropical continental. Tropical continental air approaches Europe from the southeast. This air mass mainly affects the area in the summer and early autumn months, and is responsible for the highest temperatures. It is dry, with usually cloudless skies, although often hazy conditions result, giving moderate to poor visibility. Returning polar maritime. If polar maritime air takes a large southward detour down across the Atlantic before returning northeastwards again towards Europe, we call it returning polar maritime air. It is distinct enough to have a classification all on its own. It is initially stable, but as it moves south it becomes unstable, with plenty of moisture gathered on its passage over the ocean. It is a cloudy air mass, generally unstable, with cumulus, cumulonimbus and even thunderstorm activity. That completes air masses. So now we look at the boundaries between air masses, which are called fronts.